Data Engineers Lunch number 41. I am one of your co-organizers, Josh Barnes, and today we have one of the software engineers here at Anant, Obi, and he's going to be presenting on PygramETL. We've done a few talks on ETL lately, so this will be interesting using Pygram. The organizers for this event are Rahul Singh, Arpan, and myself. And we are always looking for new members, sponsors, and speakers. So if you or someone you know would be interested in this kind of event or webinar, please refer them here. Or if there is a topic you'd be interested in learning and discussing and then presenting on, definitely feel free to reach out to one of us. Arpan or myself are probably going to have the most time to respond to those kind of requests. So definitely email myself or Arpan first. A little bit about Data Community DC. We are a diverse organization and do believe in an inclusive culture that supports people of all races, religions, gender, sexual orientation. Everyone's welcome here. And we expect respect to be given to all of those groups. You can find out more about Data Community DC at their blog, as well as any other events in addition to our events coming up. The link is listed there. And what we cover here at Data Engineers Lunch is everything related to data engineering. So ETL, data cleansing, data sources, what ends up happening with that data. So everything surrounding engineering and the different things we can do with that data is kind of what we like to cover here. At this point in the introduction, we do encourage any new attendees to unmute, share their camera, and tell us a little bit about what you do with data and what you hope to learn.
Okay, let me share my camera.
Hi, Karthik.
Hey, sorry, I joined a little late, so I missed some of the introduction on the names. But I'm Karthik Narayan. I'm a principal solutions architect at Bodo.ai. And, I'm based out of the DC area. So I just got to know about this like a couple of weeks ago. So I'm excited to be a part of this. And yeah, absolutely would like to present Bodo at some point. If any of you is interested in knowing more about the product.
Yeah, definitely reach out to one of us. Thanks for sharing as well. If anyone else would like,
could you just share your names again, because I missed that part?
Yeah, so here, let me regain control of my, here we go. So Rahul Singh's our CEO here at Anant. Arpan and myself are software engineers. And our emails are listed there. So definitely you can send an email directly to me and we can discuss having you present. That would be great. Anyone else want to introduce themselves? We can move on. So group rules, if you have a question, please ask it, be polite and courteous to others, and share what you know. This is meant to be a discussion. Obi will have his own way he likes questions to be asked, so he'll go over that once he takes over. Here at Anant, we deal with real-time data and analytics frequently for our clients. So things like Cassandra, Spark, Kafka are the three principal technologies we use. We've been using a lot of Airflow lately as well. DataStax is also a partner, and we are actually giving some partner presentations with them. The next one is tomorrow at noon. More on that to come later in the slide. George Washington University did used to support in-person meetups for us. Hopefully we can get back to that. And some of the other program sponsors are listed here, as well as the organizational sponsors to Data Community DC. If anyone has any jobs, meetups, hackathons that they would like to announce, you can take this as a moment to kind of plug anything you guys have coming up. Doesn't seem like it. We can move on. Our own announcement, Anant is hiring. We're always looking for data platform operators, engineers, and architects. These are for full or part-time positions, and you can be 100% remote. If this is something you'd be interested in learning more about, definitely check out careers.anant.us to get into contact with us. And some upcoming events. As I mentioned, the next one that's a partnership with DataStax is migrating data to the cloud and using Airflow. That one's tomorrow at noon. That'll be on YouTube Live. If you visit anant.us/events, you can get the links to the Eventbrites to sign up for that. Our next topic on Data Engineers Lunch is to be determined, and but we'll be announcing that shortly by Wednesday. And then the following week on that Tuesday, we'll also be continuing our discussion workshop with DataStax, and we'll be going through true cloud transformation. So definitely don't want to miss those talks. And that is all I have for you for the intro. With that, I will pass it off to Obi. And you might be double muted, Obi. I haven't heard any speaking coming yet.
Just normal muted, apparently. Yeah, so as you heard, I'm Obi Anamnachi. I'm a data engineer here at Anant. As a sort of point of order, I prefer to receive questions during my presentation in the chat so that I can get to them in between slides or when we move on to the demo or before we close out for the day. Our topic for today is PygramETL. This is officially the fourth part of the series, fourth and final part of the series on Python ETL tools, because as you see here, we talked about PySpark, we talked about Airflow, and we talked about Luigi before the series officially started. And then since then, we've discussed bonobos, pandas, PETL, and today we're finishing out with PygramETL, as that was the last of the ones mentioned in the start of this series, which was just a general discussion on Python ETL tools. Yes. Okay, so on to PygramETL. PygramETL, Python framework, it provides functionality for doing ETL. It supports CPython and Jython if you want higher performance versions. And you can also mess around with your settings for parallelism in order to have your tasks run in parallel. If you're using Jython, it's going to use JDBC connectors to connect to your external databases. If you're using CPython, it'll use PEP 249, which is like a Python standard for connecting to external databases. And then connection wrappers help make sure that the different connection types, wherever you're pulling data from, whether it's MySQL or Postgres or wherever, interface with your code in the same way. So something that's not actually on this slide, but this is probably the time to talk about, is that PygramETL or Python ETL tools more generally, the way that we've talked about them before, that we split them into two categories. One of which contains Airflow, Luigi, and kind of bonobos that are really about facilitating the flow of data and managing your scheduling and offloading the actual processing to external programs. And then the other type, which is more like pandas or PETL, which are about bringing your data from outside into whatever the tool's internal data representation is. And then using its own provided function in order to do your processing before exporting back into whatever storage format you use, whether that's CSV or into a database or anything like that. So PygramETL is firmly in the second camp. It's about taking your data, loading it into PygramETL's sort of ecosystem using data sources, transforming it, and then uploading it to this sort of data warehouse representation that they have. So data sources, they load data into PygramETL. it gives you an iterator over the rows, which are returned as dictionaries, where the keys are the column names and the values are your actual data within those columns. You can implement new data sources yourself as long as they meet those requirements. So it can be from literally any data source as long as you can get an iterator over all your rows, and then return those rows in dictionary form. Dimensions connect out to your external data warehouse. They act as an interface for lookup operations or for insertions. And then you can also have access to slowly changing dimensions to keep track of rows in which a few of the columns change over time, but not the entire row. Or a snowflake dimension, which can allow you to combine rows from different tables, or propagate changes outward into snowflake tables. And then the fact table holds facts or aggregations. So if you have specific values that you want in your top level table, or aggregation values you want in your top level table, as well as the foreign keys for data that are actually in tables related to your dimensions. So the sort of format that PygramETL uses for your data warehouse, sort of like this one, they have all the data flowing from the fact table, which is test results. I think these are all Postgres tables, by the way. So it uses dimensional modeling, and the sort of data flows from your fact table, which is basically only holding your most important data, which in this example is the errors value, and then foreign keys for all of your dimensions. And then goes out to your dimension tables, which in this case are date, test, and page. And then page is snowflaked out into server version, domain, etc. And so you, in the end, you commit changes to your test results fact table, and then PygramETL will propagate them out into your other tables as necessary. But as you can see, it's a specific type of relational data warehousing model that they're sort of using. You can set yourself up to use PygramETL without having a data warehouse set up like that. If you have something that you want to do with the iterators or the dicts themselves, so you could pass those into other processing if you need to. Moving on. All right, first step, extract and load of ETL. Generally, these are the same. In this case, they aren't necessarily. You can have a PygramETL program that will extract data from CSV sources or something like that. And then in the end, it's uploaded only to the data warehouse. So unless you are manually handling the load step, the only load that you can do in PygramETL is to your data warehouse. And it has to be set up with fact tables with dimensions, and organized in that sort of specific way. So your interactions with the data are facilitated by data sources and connection wrappers. So data sources hold the location of the data and information about the data and how to access it. And then connection wrappers form a uniform interface that the rest of PygramETL can interact with. You can use SQL source. It returns an iterator that iterates over the result of a single specified SQL query. So you give it your connection, you give it your SQL query, and it returns you an iterator over the rows that query returns from your database. CSV source and type CSV source iterate over the contents of a CSV file. And then you can also use pandas data source pandas source if your data is already in a pandas data frame, which we discussed when we talked about pandas. And it will give you that same iterator over dictionaries. So the transform step for PygramETL, your transformations for individual rows can be done via the manipulation of those row dictionaries. You can change them manually yourself. Say for loop that iterates over the rows returned by the iterator, and then you do the editing of the dictionary yourself with custom code. And then once all your changes are made, you insert into the fact table and changes propagate out to your dimensions. Aggregations are performed if you use PygramETL.aggregators.aggregator. There are a number of different aggregators and also the ability to write your own custom ones. So if you're defining an aggregator yourself, you define the process and finish methods, and then each row gets transformed with your process function, and then are all combined together using your method function. And there are, of course, default aggregators. The ones included are average, count, count distinct, max, min, and sum. So you have access to all of those. And then data source definitions also include some of the functionality for data transformation. So alongside the data sources that just load data from an external connection, there are data sources that modify your other data sources. So in this case, if we're talking about merge joining source, hash joining source, union source, or round robin source, they combine two other defined data sources. And essentially they'll give you back a data source whose iterator goes over all the combined rows. And then filtering source, you give it a method that returns a Boolean value, and it will enforce a condition over your data source. So if you say this column is greater than X, it will apply that function to each row. And if it passes, it will keep that row. And if it fails, it will throw it away. Process source separates your data out into batches for external processing, applying filters and applying functions to it. And then mapping source and transforming source apply functions to your data that's in another data source. So you can string all of these together in order to get a sequence of transformations. If you need to join and then filter, you can do that. All right, we're going to be moving on to the demo in a little bit. This is a good time to put questions in the chat if you have any. If you would like to follow along, we will be using Gitpod. So if you go to this link, which I will put in the chat, you can open up a Gitpod container yourself if you feel like following along. So this Gitpod container is using the Postgres Docker definition Gitpod version rather than the standard one, so it takes about a minute to boot up properly. All right. So we will start just installing PygramETL. This is the same one I had open earlier. So these are already installed, but what you would need to install PygramETL and then the Postgres Python connector. And what we have in these files right now. So the first example we're going to be going through was included in a paper called PygramETL, a powerful programming framework for extract, transform, load programmers. And PygramETL has been around for a long time, to the point where, yeah, 2009 is when this paper was produced. So if you went and got your examples and data generator yourself, they probably wouldn't work because they're meant for Python 2, but it's relatively simple fix to update them to Python 3. I think the only thing that's really wrong with them is that they're using the old Python 2 file method rather than, or yes, they're using the old Python 2 method for opening files rather than the Python 3 one. All right. So from this paper, we have their data generator. We have their Postgres schema, and we have their sort of ETL framework code. So we want to start off just running the data generator. It's in the PygramETL folder, and it's called data generator. And what it does is it creates the test results and download log CSV files. You can see they're associated by this value local file. They both have this column. And then there's test ID test ID and errors in one file, and then URL, server version, size, download date, and last mod date in the other. And if we go back to this data warehouse diagram of how it's going to work, we're going to have tables for all of these different steps. Like our data is currently in these two CSV files. It's going to join them and then separate out the data, putting it into these tables with IDs referencing back into the fact table. So we're going to input the schema. Into Postgres. It's going to create all our tables with their set primary keys, et cetera, et cetera. We don't actually have any data in those tables at the moment. If we were to open up PSQL, test results. The table exists, but we don't have any data in it. So now you can run their program and check again, and we have data. If we want to look into what this program is actually doing when we run it. So after the imports and the connection to Postgres, it defines several methods. This one is a bulk loader for Postgres. Because we're using bulk fact table rather than the regular type, we need a bulk uploader method that will put that data in Postgres. And then it's breaking out the date rows in the original CSVs into individual values for day, month, year, et cetera, et cetera. And then also assigning each one a date ID. which is what we see here. And then there is a function that extracts the domain info from a URL, one that extracts the server name from this sort of string that they have here, server version. And then here they are defining their dimension and fact table objects. So what they're doing here is they're defining them in line with how they're how they're defined in the Postgres schema. And then also defining the sort of lookup attributes, which is how PygramETL is able to tell if rows are the same, essentially. That's how it matches rows. So you can see we get cache dimensions, which are cached in memory, so they're easy to access. We have a slowly changing dimension in case I believe the date column is the one that changes. But only a small number of columns are expected to change for each row over time. And then we also have snowflake dimension for pages, which become page dimension, server version, domain, essentially data that gets snowflaked out to our other dimensions. And then we have more cache dimensions. And at the bottom, we have our fact table. It contains the key measures that you want to keep track of, which in this case is errors. And then it has your references to data that's in your other tables. And the bulk size is 500,000. If you were defining a normal fact table, it would not have a bulk size, but this speeds up the processing. Okay, and then it opens the CSVs. So it creates CSV source objects, gives it the file name and the delimiter in order to read the CSVs. In this case, they're tab delimited. And then it uses merge joining source, which requires sorted data. If you're using merge joining source, it will want your data to be sorted because that's how it determines when to switch from one iterator to the other effectively. And they're both on the local file column. And then they have their main function created here that applies some of those functions to each row. You can iterate through your rows with the for loop because it's just an iterator. So they run their extract domain info functions and extract server info functions. They set a size manually. Well, they're converting it to an int from probably a string because they just use normal CSV source instead of typed CSV source, which means all their data will come in as a string unless they do something to determine otherwise. And then they have slowly changing dimension ensure, ensure and lookup to make sure that any snowflake dimensions are being like loaded into the fact table with proper IDs. And then they insert into the fact table. They insert the row into the fact table. It propagates out into their dimensions. And then they use connection.commit to push that data into Postgres. And that's how we came to have their fact table all set up in Postgres. And then we also have a second example. If people were here for, not this one, the PETL presentation that was part of this series. We use PETL to work with a wine quality database, which we also used in our machine learning with Spark and Cassandra one a long time ago. Essentially, we did the same sort of setup that we did there to prepare the data for our machine learning algorithm. which in this case is filtering out wines with quality below a certain threshold, making sure that each, even though they end up in the same table, each one is labeled with the type of wine it is, because we start with two separate CSV files, one for reds and one for whites. So we label them, we filter out any ones that are below a certain quality. We calculate from other rows a max acidity. The CSV gives us fixed acidity and volatile acidity, which we add together to get max acidity, and then locked SO2, which we calculate from total SO2 and free SO2. This one proceeds to sort the combined table, but PygramETL does not have an easy way to do that. But we're going to replicate the rest of the processing in our PygramETL ones. And this is also sort of going to be an example of what I talked about with bypassing the sort of data warehouse setup that they want you to have just by working with the iterator. Essentially, we're just going to take everything and print it out to a file, rather than put it into our data warehouse. Okay, so basically the same up top. We are still creating this even though we don't need to because it's based on the other file. So this is, I'll use this as just the connection out to Postgres, which we're not actually using here. And then we have our own functions that we have created. Calculate max acidity, calculate locked SO2, red wine filter, white wine filter, because we decide they have different quality thresholds. And then add ID red and add ID white, because the contents, the actual columns within these don't specify. The only way to determine whether it's a red or a white wine is which file the row came from. So we are labeling them in the code. We don't do any dimension or fact table creation because we're not uploading to a data warehouse at the end. So we create our data sources. In this case, we're using type CSV source, and we have types defined for all of our for all of our columns. We use transforming source, which allows you to apply a specified function that returns a row to all the rows in the source that you give it. So we give it our red wine source. It adds the ID. It adds a unique identifier and the type of wine that it is. In this case, red, to all of the red wine rows. And then we filter with our quality metric. And then we have the same for white wines. And then we use round robin source, which I don't think we talked about very specifically, but you give it any number of sources in a tuple, and it will iterate through them, grabbing batch size rows each time, in this case 20, and sort of interleaving them from each of your different files. So in this case, when I was testing this, I had some issues because I was printing it all to the console. And expecting to see, 20 red wines, 20 white wines, 20 red wines, 20 white wines, etc. And I was looking at all white wines, and it's because, our red wine list has maybe 2,000, 1,500 wines in it. Yeah, 1,600 wines, while our white wines list is much, much longer. There are 5,000 just about rows in that one. So in this case, all we do at the end, we iterate through the merged data source that we called input data. We apply our functions, and then we output to file. So we can do that and then look. In this case, we have our 20 reds, we have our 20 whites, and we will at least until we run out of red wines. Luckily, Python iterators aren't circular, at least in the way that we're getting data from them. In this case, you can use iter_tools cycle rather than just the normal way we're using the iterator now to get a circular iterator if you wanted one. But in this case, luckily, because we're not getting duplicate red wines, which we would if they were mismatched in this way, and we're using a circular iterator. But once it runs out of red wines, it will request 20 from the iterator, get nothing back, and so it will put nothing into this table and then continue on with the whites, which we can see if we scroll down. It's all white wines after a certain point because we just have a lot more of those. All right, so some resources for PygramETL. Obviously, the main page, which is what we were looking at earlier. It has the data warehouse diagram as well as the code example from this paper down here, which is the one that we discussed. And then there are the docs, which have information about how to use all of the various data sources, how to work with dimensions and fact tables, et cetera, et cetera. And then if you wanted to read that 2009 paper, you could. And it has the same sort of diagram here, as well as a comparison to, here we go. They're comparing it to a sort of visual graphical interface BI tool in terms of performance. All right, that's all I've got for today. There is more time for questions. If people have those, they can put them in the chat. And since my presentation itself is basically over, you can also unmute and speak up if you have questions you'd like to ask.
Thanks, Obi. Are you able to incorporate PygramETL in some other pipelines we've talked about recently, like or like schedule it in Airflow, that type of thing?
Yeah, it's straight Python code, so it's easy to schedule in Airflow as long as you know where your data is and where it's going. So for example, unless you want to use Airflow XComs, it's not going to pass data in between tasks for you. So as long as you know, say your data warehouse is fine, that's where your data is going once the PygramETL task is finished, because you don't want to lose it, essentially.
Gotcha.
But yeah, it's definitely possible to integrate. It's very easy with something like Airflow or Luigi because it's all Python code. As long as you have your import set, you can do basically whatever.
Cool, thanks.
Is there any GUI or something for Pygram? Or is it just completely command, I mean, like coding based, like Airflow?
No, PygramETL is all code. Like I said, one of the comparison that the authors of that paper at least wanted to make, I don't remember the name of the program, but it was to a sort of graphical interface, sort of ETL or data flow definition program. But they wanted to emphasize that they have better performance and et cetera, et cetera. And they don't have a GUI of their own to draw that comparison to, I guess.
Okay. And it doesn't have any distributed support currently?
No, you can parallelize on a single machine. but it doesn't have any real distributed capabilities.
Thank you.
So I know you said you had to program it in the demo, that file with all the different methods, not specifically the ECL, but the loading and where it was going and stuff. Did you have to write that, or does it give you like a scratch file that you then just fill in? What was like the level of effort it took to create that?
So for which part?
Kind of where you were, like where you, at the top of the file, you have your connectors, and then below that you wrote a bunch of different code with methods like, I think specifying like where the data was going or something.
So there is.
Yeah, this is the file.
At the top, they have their code that defines the connection to Postgres. And that's mostly, so connecting to Postgres using the Python connector is a standard thing. So this here, that connection is a standard thing. And then you proceed to wrap it in the PygramETL connection wrapper, which will, I mean, once you create it properly, it'll work the same for any sort of data warehouse that you're connecting to, whether it's MySQL or Postgres or whatever.
And then you write all the methods.
Yes, and then these
define all
methods.
that.
So they define the bulk loader method because they're using bulk fact table. And then they define these other methods that work on individual rows, which are pretty easy to manipulate because, like I said, they're just a dictionary.
Oh, so that stuff, there's like, it comes with PygramETL, and then you can kind of manipulate it to whatever your use case requires.
Yeah, so the only real difference between what they're doing here and what I'm doing in this one is that they're applying a lot of their functions down here in the for loop in main. Whereas up here, because you don't want to iterate through your data sources before all your transformations are done. Basically, until you have your final data source, you don't want to use a for loop to iterate through. So in the wines one, you can see we're using transforming source and we're using filtering source, where theoretically you could use a for loop that would go through and you would, apply your filter to each row individually, or you would transform each row individually. But then the original, say this red wine source, would be exhausted because we already iterated through it.
Gotcha.
So we're using transforming source and filtering source so that by the time we get to creating our round robin source, red wines filtered and white wines filtered still have all the data inside them.
Gotcha. Thanks.
All right, if there are no more questions, I'm going to sign off.
All right. Thank you everyone for joining. Thanks, Obi, for the great presentation. Yeah, I saw Kevin was able to get to our YouTube channel, so be sure to like and subscribe if you're watching there. And yeah, thanks everyone for joining.